Hello everyone, myself Tanay Kulkarni. I'm a technical consultant for water and wastewater solutions and I belong to the global water team at Bentley Systems. In this video, I'm gonna show you how Bentley hydraulics and hydrology products can be useful for water and wastewater systems modeling and designing with the existing GIS data that we have. For that, let us first review the GIS data in Arcgis for a particular network like this, in which we have road boundaries, junction shapefiles. In junction shapefiles, let me open the attribute table in which we have elevations and labeled. The elevations are initially 0. We also have pipe shapefile in which we have properties like material or the scale length or label. Initially, the draftsman didn't know what the diameter should be, so he set all pipes to minimum commercially available pipe size, that is 100 mm. Now this green layer that we can see on the screen is the population distribution in that particular ward number 14. This ward has got residential, commercial, institutional, etc. population data and the demand projection for next 15th and 30th year. Everything in this attribute table is partially referenced. We also have contour shapefile which has all the elevation data that was collected from the total station survey. Let us now export these GIS layers as shapefiles. Please note, we are going to create a hydraulic model of this network and design it and analyze it in Watergems. After exporting the layers as a shapefile, let us now open Watergems. You can bring the aerial imagery or CAD layout file as a background image. Using Model Builder, you can very easily create or build your hydraulic model from the previously exported shapefiles. You can also have a preview of the data that is available for import in those shapefiles. All you need to do is to match the property in the GIS with the property of that element in Watergems. It asks you, would you like to build a model? You say yes and then finish. That's it. It will give you a model builder summary and it has created a model. You can note that all the data that was there in the shapefile was successfully imported in Watergems for both the elements, junctions and the pipes. The junctions in this model have no elevation data. In order to assign the elevation to the junctions, there is a tool called as T-Rex, which is terrain extraction tool. It will help you to automatically assign elevation to all the elements. You can have a preview of all the elevations of the junctions. We can also go to the flex tables of junctions to see whether the elevations are imported or not. Smart load assignment to all the junctions has been a time-consuming and troublesome task for the modelers in the past. In Watergems, you can use the tool known as Load Builder, which will allocate the demands to all the junctions automatically from population shapefile that we have exported from GIS software. After building the load, you can save all the demands in a completely new alternative that can be used as separate what if condition. We can then go to tools and the tool name as Demand Control Center to take a look at the individual demands at the junctions. Using Darwin Designer, we can optimize the diameters of all the pipes in our network for minimum cost design. In this tool, we can specify our constraints that are laid by CPH-EEO for minimum pressure, minimum velocity and maximum velocity. We can provide our CSR record After computing Darwin Designer, we'll get optimized diameters for optimal cost of the network. We can export the solution to a scenario. When we make the exported scenario as a current scenario, all the optimal diameters will be reflected and will be color coded. The diameters will also be reflected in the flex tables for pipes. And then we can compute the network with optimal diameters to get the hydraulic results. Once we get the optimal design, we can simply sync out using Model Builder to synchronize all the modifications back to the source shape files. Now when Draftsman goes back to GIS and attaches the synced shape files, he will be able to see or reflect all the modifications and changes that are hydraulically correct for that particular network. Like in this case, the diameters are updated from 100 mm to the optimal size. And all the junctional elevations were also updated. In this demonstration, we saw how Model Builder can be used to create a model with the GIS data, how T-Rex can be used to assign elevations to all the elements from terrain GIS data, how Load Builder can be used for automatic load assignment, and how Darwin Designer can be used for optimally designing the network under constraints for least cost. Watergems Gems and Hammer are completely integrated with ArcGIS.